M1 Dynamics, example 3. In these examples, we've got some forces acting vertically and some forces acting horizontally. And what we've got to do is find the magnitude, the size of the unknown force X and Y. So, in each case, if we resolve horizontally and vertically, we'll be able to work out the missing force. Now, vertically, for the first example, there is no acceleration. This is in equilibrium. So the particle or the object is not accelerating upwards, it's accelerating from left to right. So we can assume that these two forces, y and 2g, are equal to each other. There's no acceleration vertically. So y is equal to 2g, and 2g is 19.6. Now, if we look horizontally, we're going to have to use F equals ma. So we're going to resolve these forces and say, okay, we've got in the direction of motion, which is from left to right, we've got X going forwards, and we've got 4 going backwards. So that's resisting motion. So I can write that as X minus 4 as the resultant of those forces. That is equal to the mass, which is 2, multiplied by the acceleration, which is also 2. Rearranging this tells us that X is actually 8 newtons. Same thing on the other diagram over at the right hand side. If we start by looking vertically, there's no acceleration vertically. So that means that the forces upwards must be in equilibrium with the forces downwards. So force upwards is Y, and you'll notice that we've got a 20 newtons, but it's forcing down onto the object. And we've got 4g as well acting down. So forces acting up, forces acting down, they're in equilibrium, they're equal to each other. So 20 plus 4g, that works out to be 59.2 newtons. Same as I said earlier, we should really be rounding these to two significant figures. So we should really be rounding that one off to 59 because the value of g is correct to 2 significant figures. And really over here we should be doing the same. 19.6, we would round to 20 to 2 significant figures. Looking horizontally, just be careful because the acceleration is to the left. So right to left is the direction that I'm going to take as positive. So I'm going to resolve in that direction. So the 80 is positive and the x is negative, and they're the only two forces acting horizontally. And that's equal to the mass, which is 4, multiplied by the acceleration, which is 2. So 80 minus x equals 8. So I think x must be 72 newtons.